Let's talk about one of the major types of sedimentary rocks, which is called chemical sedimentary. So chemical, think chemical, water is the most common type of chemical you could ever think of. Think H2O, it's its chemical notation, right? And so it's rock made from a solution or kind of like a mixture between minerals and water. So here we have an example. Here's water, and this water is salt water, let's say. It's completely full of salt. We don't see it because it's so perfectly dissolved within it. But then over time, as this water evaporates, the salt is what's left behind, and then those salts condense and they combine to form in salt crystals. We call that halite. So here's an example of what the halite looks like right over here. It's like rock salt. And then over here you have gypsum. So gypsum forms in a very similar way with the water evaporating, and then this is what's left over. So halite, rock salt, it's used in the common rock salt that would be you might be using during wintertime, or you might see the trucks go around and they drop off the rock salt in the street. The reason that that happens is because salt water freezes at a lower temperature than regular water. So if regular water freezes at 32 degrees Fahrenheit or 0 degrees Celsius, salt water freezes at a lower temperature. So that means it could be freezing cold outside. It could be ice, but when you put the ice on top of it, it causes the water to melt. It won't work if the temperature is way too low, but for the most part, it does tend to help out a lot. Gypsum is, I believe, a type of rock that's used in things like chalk and plasterboard, wallboard, things like that. Now, the next type of sedimentary rock is called clastic sedimentary, not to be confused with the word classic. But I like that word classic for this because when you think of sedimentary rocks, a bunch of sediments smushed together, that's pretty much what this is, right? It's rock made of fragments of other types of rocks and minerals. So we already talked about conglomerate. Remember, conglomerate was our example here of all the different pieces that are together, right? So a couple different examples of conglomerate. Reminds me a lot of actually concrete, like what you'd see outside, all those little pieces that are mixed together, and then this part that's connecting them will be like the mud that's keeping them together. Then you have shale. Shale is basically just a bunch of mud that got compacted enough together that now formed into a rock. And then you can see different color muds produces different kinds of shale. You can also have oil shale. And then if you have oil inside of it, you can burn that and get energy out of it because oil comes from dead organisms. And some of those dead organisms get mixed into the mud, and therefore you can get energy out of that. And then here we have sandstone. So sandstone, you can see that there are different colors sandstone because there are different colored sands. And you can see the layers in here, right? That distinct gives it away that, of course, that we're looking at a sedimentary rock because of the layers. But as this video shows us, that most sand actually looks the same, and there's actually a pretty cool reason why. So I definitely encourage you to watch this video to find out why does all sand look the same. Now, to go opposite of that, of course, there are different beaches that have different types of sand here. Here we have Hawaii, black sand. Why would that be? From the volcanoes, for the volcanic rock that comes out, and then that's the type of rock that gets eroded away. But most places are not, a volcanic island, so most places don't have that exact type of black sand beaches. Here we have the U.S. Virgin Islands, not that different than the types of sand you might see in like New Jersey. It has that like similar-ish color. But over here you have in England and other places, when the rock hasn't been eroded away enough, you get these other types of beaches there. That are much bigger and thicker and a lot more painful to walk on top of. And then the third and final type of sedimentary rock is called organic sedimentary. And this is the rock that's made from the remains of plants and animals. So here's one of them. You can see, if you ever see a shell inside of the rock right here, that means that the rock is literally made up of little pieces of shell. So here you can see this is definitely a dead giveaway that this is sedimentary rock because it has something that was living. If it has something that was living inside of it, like a fossil, right? This is the only type of rock that you're ever going to find fossils inside of. So anytime you see fossils, like shells, fragments of life that was once there, definitely sedimentary. And in this one, it makes up literally the rock is made up of fossils, things that were once living. Now here is coal. Coal is the dead plant and animal matter that was not decomposed entirely, and it just over time you could see like here's a swamp, right? And here's the peat that's left over underneath there. And over time, all this stuff dies, it gets compacted together, and then there's more layers on top of it that's adding that pressure down to it until it becomes coal. You can dig out the coal, burn it, use it as energy, right? Apparently, it's all just carbon, right? So the way that these trees get their energy is from the carbon dioxide in the air. It stores that and then it gets released. That's what happens when you burn coals. You're releasing that carbon back into the atmosphere, which is not what we want to do when we have a problem with too much carbon dioxide in the atmosphere causing global warming. But that is how coal works. And apparently, if you squeeze coal enough, since it's just carbon, you can actually change it into diamond over a really long time with an incredible amount of pressure and heat.